Hi, my name's Stuart Walker from RMS, and this is my colleague Keith Gallant. And we're here today, we're at a biomass power plant, and we're here to introduce some of the wireless technology we've been developing with sensor tech in Ireland over the last few years. This is the Kappa X, and it's amazing technology now. It's come on leaps and bounds in the last few years. So this sensor we've developed with sensor tech's got a lot of RMS in there, the form, the size, how it works and the software. But before we go on site and show you how it really works, I just want to chat with you, Keith, about wireless technology. Why would I want to do wireless when I've been successfully using my analyzers and doing monthly routes, let's say, collecting data? Why do I want wireless?
Well, with the wireless, you'll have a gateway, you have your sensor, and that's just going to send data continuously to the cloud. So it'll collect a measurement every minute with this system, and then that goes straight to the cloud. You can view it anywhere in the world. You can be sat on the beach and look at the data.
Yeah. So for me, one of the biggest benefits, if you agree, would be the resource of like not having to go out and collect that data.
Yeah. So you said maybe monthly you do a route. Well, with this, you're going to collect measurements much more frequently. With the Kappa X, you're looking at every minute you're getting a measurement from the
Yeah. So that is a massive difference between monthly and once every minute catching data. And I think that's the other benefit with this system, is that you start capturing those 10-20% that you tend to maybe miss on a monthly vibration route, lubrication problems that can occur quite quickly, and it just has the ability to capture that, maybe send an email and take it from there. It's truly a bit of a game changer, but for us, I guess it's not a case of throwing a load of sensors on there and walking away. It's got to be part of a CBM system. You're still going to have to visit that machine, maybe do some more measurements. It's certainly not throw them in and walk away. So let's get on site, let's get this system set up and show you how easy it is to get going and getting some data, and we can get the vibration and temperature data quite quickly.
Okay, so now you can see we're on site. We are on a power station with lots of different equipment. There's pumps, there's fans, there's a lot of pipe work. And what we picked for us to put the wireless equipment on today to test is this boiler feed pump. So there's a motor and a pump. Both of them are very critical to operation here. And as you can appreciate, all the steel work and the pipe work, it's very difficult to penetrate with traditional wireless systems. This system uses a low frequency proprietary technology, which is going to give us a really good range to penetrate through the building to our gateway, which we'll set up later. Right, so on the machine now, we've got 4 sensors out. We're going to put them on this boiler feed pump and the motor, and I'll walk us through that. So, could we just put one sensor on the motor like this? Well, we wouldn't get very good data coming back to the sensor from each bearing. You can see the distance here. We've got a drive end motor bearing and a non-drive end bearing there. And what I want to do is get this sensor as close as possible to the source of vibration for high quality data. It's no good having all the data points with poor quality data. So I'm going to put this here on the bearing end cap. Now you can see this sensor has been designed to be nice and thin profile on it, slots in, and a small footprint. That's also really handy for at the back of the motor, because I can get it just there on a nice solid point, off the fins and away from the fan cowling. So before we do the pump, let's have a quick look at the sensor. It'll measure vibration in 3 axes. In one axis we can do a 10 kilohertz measurement, and that will look at things like high frequency bearing defects, lubrication problems. Another nice thing it does on there is it takes the temperature as well. So we can also, when we do things like lubrication, we can see that temperature change over time in real time. It's really nice for that. So nice thing about the design, like I said earlier, we've got quite a slim profile, and on this sensor we've got a magnet mount. Because it's slim, I can just get that into a tight spot nice and easy. But if we wanted to, we could also put a stud mount on there and permanently mount it using a thread and tap. Last sensor then, on the non-drive end of the pump. So you might be thinking about the battery. How long is it going to last? Well, thanks to SensorTech's well-developed proprietary low-frequency wireless technology, the battery is guaranteed for at least a minimum of 3 years. When you get to the end of that 3 years or beyond, and you need to replace the battery, it's just a low-cost battery off the shelf that the user can replace themselves by taking the cap off, swapping the battery. So what's important now is that we can connect to these sensors and put the gateway somewhere more practical rather than next to the machine. So that's important then that we have a good connection in distance. Now if we have a line of sight to the gateway and the sensor, we'd probably look at about 100 metres, maybe a little bit more. In reality, on the plant here, where there's all the metalwork, steelwork, we're looking more between 40 to 60 metres on this plant. So we'll go and set that gateway up and connect into these sensors. Right, it's time for the gateway. So the gateway is going to connect us from the sensors and connect us to the cloud. So it's going to receive the data in from those sensors and then relay it up to the cloud for us to view later on the HMI software. There's a few ways that we can connect to the internet. So this one is a cellular connection. It's got a SIM built into it. That'll connect to multiple networks and then therefore onto the internet. The other way is through Wi-Fi. So if there's plant-wide Wi-Fi, you can just connect through the Wi-Fi. Another way is Ethernet. So you can have an Ethernet port on there and go hardwired into the internet. So the other thing about that is we also need to power this gateway. Here we're going to use 240 volt. We're just in a nice little room next to the control room, so we can do that. If we're out on site down there, we could use 110 volt or 12 volt is fine, straight into this, and we can place that on the outside of a control panel or somewhere nearby on plant where it's got a nice open connection. Right, so we're going to connect it now. I estimate we're about 50 meters away from the sensors through the plant, so that's pipe work, steel work, concrete and so on. So I'll plug it in and see if we get that connection straight away. Green light. I'll leave that flashing for a little bit. That's going to search for the internet and for the sensors, and then we should get a nice blue light, and that will give us the all okay. There we go, now it's turned blue, so I know I've got connection and I can start receiving data. We've had a little bit of a break for about half an hour there. Just let the data come in and start registering into the cloud, and we can now take a look through the browser and the HMI software to see what the data looks like. So I'm going to show you that now. So logging into the analytics, we can see we've got a few sites there, got a nice map of where the different sites are, and the one that we're at today we're just going to look at just here. It's a biomass power station. So I can click on that and it takes me straight into the site level. You can have a map here, it shows all the site and all the different locations and so on, and it populates with your machines here, any alarm events. So this is a real top level view just to get a quick overview of the site and its condition. Obviously we've just got that one boiler feed pump we're looking at. That's here, all in green, so it's a good start. When I click on there, we've got some customization. We can have images, so you've seen where we're looking at that machine there. We've got the photograph of it for reference. We've got also a map there of where the sensors are, and we can start looking then, drilling down into each sensor, seeing what the data's like. So again, because we've only got half an hour and it's in good condition, we haven't got a lot of alarms coming in yet, which of course is a good thing. So from this top level bar along the top there, I can swap from point to point, from machine to machine, and from different sites. So in my overview menu, I've got the diagnostics, which is going to look at all the technical bits to do with the sensor connection and so on. The environment, that's where we're trending our temperature level. We've got a vibration, that's the minute by minute trends that we've got. And then we've got long interval data. So that's given us a spectrum. So the way this system works is we get a measurement from the sensor each minute. So every 12 hours we will then get a full spectrum, and that will be in the long interval data. So we'll have a look through the different types there. The environment one, let's go to the motor drive end. It's a bit warmer, that bearing, and you can see it's warmed up and we've got that incremental data. And of course it's each minute by minute will be a different point of data that it's bringing in, so it might be temperature, or it could be the vibration overall, velocity overall, or the acceleration peak to peak G's. So that's why you can see there from minute to minute it's changing. So moving on from environment, I can go to the vibration, and here I've got acceleration RMS overall, velocity RMS overall, and a real nice one to trend peak to peak in G's, and that's given us again on that trending measurement that we want. So as we move along our trend there, we can see the overall velocity level changing on the machine. And we can go from each plane within the sensor, so vertical and axial, and we can also then go to the spectrum. Now on this system, obviously we've only been there half an hour, so I've got another spectrum to show you from a machine that's been collecting data for some time now. So here we are on a fan drive end bearing, and we're looking at the acceleration spectrum and an acceleration time waveform. And in the time waveform you can see some impact in there, very low level, about 2 G's peak to peak. I think it says there a max of 3.87 G's peak to peak. And this is at the 2.5K FMax, which obviously is not the full range that this sensor can do. We've got that 10K as well, so let's have a look at what the difference is in the data when you go to that 10K. So we hit here, full spectrum, and look at that, that's very different, isn't it? So just now we were looking up to around here, 2.5K, and now we've got a spectrum all the way up to 10K, right to the end there. And you can see all the data that's in there. There's a lot more information within that reading than there was in the previous one. And that's of course because our time signal has got a lot more information in it. So you can see here, actually our impacting now looks more like 21 G's peak to peak as a max there. So we're averaging just underneath that by the looks of it. So yeah, big difference between the two data types there. And it's really key that we get that 10K to be able to look at those high frequency bearing defect problems. So that's the spectrum at 10 kilohertz. And what's important of course with that is how we are looking at the alarms and events that we need to be alerted to for problems. And because we are collecting this data every 12 hours, we've got that full spectrum. We can actually get really nice trends from those spectrums, just like you would do with a normal day-to-day handheld analyzer. So we have that in our vibration spectrum trending. That gives us power band alarms in that from the spectrum that we can see there. We've got some nice trends coming from this machine, And of course, real key one there from the waveform is the peak to peak in Gs, and we've got a nice trend from that over time. So looking across there back to our site that we've got here today, we've set up, none of those alarms are coming in, but we would see the alarms appear just here on the right hand side, and then they would give us quick links into those machines to review the data. We could also have that set up to give us an email or an SMS message just to alert us to go and look at the data. Now what you can also do is use the API from this system to export the data live to a dashboard that you've created for your site, or that can go to the DCS system or whatever sort of system you want to export that to give you that live view of the data. Anything that's in here will be able to be exported for your own dashboard.
Thanks for that, Keith. Brilliant overview there of the technology. You've seen there, it's quite simple to set up, not too much trouble, and the beauty is now I can look at this machine anywhere in the world on my phone, and like Keith's shown on the internet, so absolutely fantastic. Keith, we've done quite a lot of trials with this system and had some great success, so I guess we're going to start putting out some real technical little case studies, examples.
Yeah, I should think so. We've got quite a lot of data coming in now from various places where we've seen so much more detail in the data because you've got that minute by minute increments.
I know, that's the thing, and I had one the other week where we actually I was in the office at home and I was asking the guys to grease on site, and I could actually see pretty much not far off real time when they greased it, the temperature go up, and asking them to put a few more shots in until the vibration dropped. Quite amazing, really. So like we said early on in this video, for us wireless, it's definitely coming. It's an amazing technology if applied on the correct equipment, but it needs managing. It's like any of these things, you don't just throw a load of sensors in, it needs managing. So thanks again, Keith, and yeah, we'll speak to you soon and show you some more content.